Now that we're on to part B, I actually want to point out that part B and C are almost the same, other than one's approaching positive infinity, the other one's approaching negative infinity. And the thing that's interesting about this is these two limits will actually come out to be different numbers, while our previous example actually, whether we approached positive or negative infinity, it came out to the same thing. And we actually didn't talk about it, but if we look at our argument here, none of it depends on x being negative or positive, right? These limits down here, these will all go to 0. All those ones that are going to 0, they'll still go to 0 as long as x is going to positive or negative infinity. Okay, so all this is independent of whether we were approaching positive or negative infinity. And so a nice little side note here, even though we didn't talk about it when we did this problem, is that the limit as x approaches minus infinity of 5 minus 3x plus 2x cubed all over 6x to the 4th minus x squared, we know that this is equal to 0 as well. Let's go ahead and move down here now. Now, the reason that these two limits are going to approach different values is in part because there's this square root here, okay? And the square root here, it does make things a little trickier. We're still going to actually divide by 1 over x, but I need to mention something about 1 over x here. So normally you all would think about this as the square root. Let me get there. There we go. You would think about this as being equivalent to this. Okay, and it's not always true, unfortunately. Okay, or I suppose if we really wanted to, we could write this in even a different way, like this. You might prefer that, but either way, this isn't always true. Okay, we actually want to think about this in two pieces if we're going to try and rewrite it in that way. So one of the pieces is 1 over the square root of x squared. Okay. But sometimes 1 over x is negative, right? This thing here is always positive because you're squaring something and then taking the square root. So this is actually only true if x is greater than or equal to 0. And if x is less than 0, it's actually minus 1 over the square root of x squared. Okay. And since we're approaching positive infinity in part B here, we will use this expression. But in part B, we're actually going to have to use the bottom one. Okay. So let's start writing out this limit again, and then we'll make our first move here. Okay. So I have 1 over x to the highest power from the denominator. But when I do this with the square root, it's just easier if I use this other notation over here with 1 over the square root of x squared. So 1 over the square root of x squared. And the reason that this is going to be easier is we know that if we were to take the square root of one number over the square root of another, it's just equivalent to the square root of those two numbers divided by each other. So this becomes the limit as x approaches infinity. And it's going to get messy for a moment. We're going to have the square root of x squared plus 5. And remember, since these are both in a square root, I can use this rule right here. So I could divide by x squared. And we'll simplify that here in a minute. And then the 3 minus x, we'll go ahead and we'll divide that by x. So we're going to have 3 over x minus 1. Go another step further here, the limit as x approaches infinity. And this is now of the square root of x squared over x squared is 1. And then 5 over x squared is just 5 over x squared. And then in the denominator, we still have this 3 over x minus 1. And you'll notice we have two terms in here that are a constant over x to a power. Okay? And we know that those things go to 0. So to finish this off, we have the square root of 1 plus 0 over 0 minus 1. So this just becomes minus 1. And let's try out part C. Let's see how this one's a little bit different. Okay. I'm going to actually start it off in almost an identical fashion. We have our limit as x approaches minus infinity, and then we have the square root of x squared plus 5, and then this is all over 3 minus x. So that should all look the same. We haven't done anything. And this next part is going to start off looking the same. I have my 1 over x. And then here in the numerator, I'm going to have 1 over the square root of x squared. So that looks the same too. There's only one little difference here, and that is a minus sign. Okay, let me maybe write it in a different color so we can remember what on earth is different between these examples. There we go. And again, this is just because if x is less than 0, 1 over x is equal to minus 1 over the square root of x squared. That's all that's going on there. And then the rest of this is going to look pretty much the same. Our answer is only going to change by a sign. So this is the limit. Actually, I'm going to give myself a little bit more room. Equal to the limit as x approaches minus infinity. And again, I have that negative in here now, so I have minus the square root. And then I have x squared over x squared, which is 1, and then 5 over x squared again. And then this is all over 3 over x minus 1. And now, again, we have constants over x to positive powers. So those things are going to go to 0. And all we're left with here is minus the square root of 1 plus 0 over 0 minus 1, which this time gives us positive 1. Part D, this is going to be a little bit different. We actually need to know one thing here. If we were to have the limit as x approaches infinity of, let's say, r to the x, well, this thing's going to be equal to 0 if that r that you have there is between 0 and 1. Okay? And the reason for this is let's say we had r equals 1/2. If you do 1/2 to the 1, right, you have 1/2. 1/2 to the 2 is 1/4. 1/2 to the 3 is 1/8. Right? This thing is going to keep getting smaller and smaller and smaller every time you increase that power by 1. This is going to go to 0. Okay? But this is the trick that we're going to need here, or rule that we're going to need that's going to help us. And I like to think about this a lot like the ones that we were doing up above. Even though these are all exponentials here, not polynomials, we could take the exponential that has the largest base and divide by that. So we could do the limit as x approaches infinity of 2 to the x plus 3 to the x over 2 to the x plus 1. And again, I would find that exponent with the largest base in the denominator as kind of a general rule. if you have exponentials in here like this. All right, and then next, let's go ahead and then divide everything then by 2 to the x. So we get the limit as x approaches infinity of 2 to the x over 2 to the x plus 3 to the x over 2 to the x. And then this is all over. And then we're going to have 2 to the x over 2 to the x and plus 1 over 2 to the x. And I'm realizing, looking at this, that I need to add a little bit more to this. Okay. If we were to take the limit, here we go, the limit as x approaches infinity of r to the x, this isn't always going to be 0, right? Because we had this here. Well, if r is bigger than 1, okay, if r is bigger than 1, this thing's going to blow up. Okay. And you could also imagine if r was equal to 1, then the limit would be 1. Okay. But we don't have to worry about that here. So next step, simplify a little bit further, and then we can use one of those 2 purple rules up there. So we have the limit as x approaches infinity of 1 plus, and now I'm going to write that as 3/2 to the x all over 2 to the x over 2 to the x is 1 plus, and again 1, how about we write that as 1/2 to the x. So what will happen here is the 1 will stay as 1. This thing here is going to go to 0. Okay. So the denominator is approaching 1. What's the numerator doing? Since we have that 3/2 to the x, if you keep multiplying something by 3/2 over and over and over, it's going to keep getting bigger. Okay. So the numerator is continuing to grow while the denominator is just approaching 1. Okay. So this thing is going to blow up. This limit's infinite.